In the summer of 1969, 3 men ate breakfast in the quiet hours before dawn, their bodies already sealed inside suits designed for a world without air, without weight, without the familiar pull of home beneath their feet. There is something almost dreamlike in the slowness of that morning. The careful rituals of preparation, the long drive to the launch pad where a rocket taller than a cathedral stood waiting against the Florida sky. If these quiet journeys through history bring a measure of rest, the subscribe button is always there. A small gesture that helps these narrations continue. But for now, there is only the story itself, the hum of machinery, the breathing of astronauts, the vast and silent distance between the Earth and the pale surface of the Moon, and the extraordinary, ordinary humans who crossed it. Let us begin there. A pale blue evening in 1969. The 16th of July in the year 1969 arrived in Florida the way most summer days do, along that stretch of Atlantic coastline, with the gradual warming of humid air and the slow brightening of a sky that had been dark and star-filled just hours before. The Weather Service had predicted partly cloudy conditions, and indeed there were clouds, soft and unhurried in their drift across the pale morning blue, casting shadows that moved like gentle thoughts across the sandy expanses and the scrubland and the long, flat highways that led toward a place then known as Cape Kennedy. The temperature would climb to 85 degrees Fahrenheit by the middle of the day, which is roughly 29 degrees Celsius for those who think in such terms. And this warmth would settle over everything like a familiar blanket. The kind of warmth that makes you want to sit very still and let the hours pass without rushing them along. Along the beaches and the causeways and the roadsides for miles in every direction, people had been gathering since the evening before, and by the early morning hours of that Wednesday, their numbers had swelled to something approaching 1 million souls. Though, of course, no one was counting them precisely, and estimates of such crowds are always somewhat approximate, shaped by the enthusiasm of those doing the estimating and the difficulty of knowing where a crowd begins and ends. They had come from all across the country and from other countries too. Families and couples and solitary individuals, all drawn to this particular curve of the Florida coast by the knowledge that something was going to happen here, something that had never happened before in all the long history of human beings walking upon the Earth and looking up at the Moon and wondering. The families had set up lawn chairs, the kind made of aluminium tubing and woven plastic straps in colors like avocado green and harvest gold, and that particular orange that seemed to belong so specifically to the late 1960s. Children sat on blankets spread over the sand or the grass or the warm hoods of parked automobiles, and their parents had packed coolers with sandwiches and cold drinks. Because waiting is hungry work, even when the waiting is for something extraordinary. The smell of sunscreen hung in the air, that distinctive coconut and chemical fragrance that meant summer and meant being outdoors and meant that someone cared enough to protect you from the sun. It mingled with the salt smell of the ocean and the exhaust from idling cars and the occasional drift of cigarette smoke. All of it combining into an olfactory signature that those who were there would remember for decades afterward. The way certain smells attach themselves to certain memories and never quite let go. Transistor radios crackled and murmured throughout the assembled crowds. Their tinny speakers carrying voices that described what was happening and what was about to happen and what was about to happen, providing narration for an event that many in the crowd could see with their own eyes if they looked in the right direction, toward where the launch complex stood against the horizon. These small radios, powered by batteries and held in hands, or set on dashboards, or balanced on the armrests of lawn chairs, represented a kind of miracle that had become so ordinary that no one thought of it as miraculous anymore. The transmission of human voices through the air itself carried on invisible waves to be received miles away by anyone with the right device and the inclination to listen. The voices coming through those speakers were calm and informative, reading facts and figures, describing technical preparations, filling the time with words that meant something and words that simply meant that something was coming. In New York City, in a CBS television studio that had been specially constructed for this occasion, a man named Walter Cronkite sat before cameras and microphones, prepared to guide several 100 million people through what they were about to witness. Cronkite was known for his steady presence and his authoritative delivery, and he had been broadcasting news to American households for many years. By that point, his face and voice familiar in a way that made him feel like a trusted neighbor or an uncle who could be relied upon to tell you the truth. His broadcast setup included models and diagrams and screens showing various camera feeds, all the apparatus required to explain a journey that would cover approximately 240,000 miles and yet begin right here, on this humid Florida morning, with fire and noise and a machine rising slowly into the sky. Across the globe, in living rooms and public squares, in pubs and cafes, in places where it was morning and places where it was the middle of the night, an estimated 600 million people prepared to watch. This was a number that represented a significant portion of all the human beings alive at that time, gathered not physically but through the strange intimacy of broadcast signals bouncing off satellites and traveling through cables, all to share in the witnessing of a single event. In some places, people would watch on small black and white television sets, the images grainy and ghost-like, while in other places there were no televisions at all and people gathered around radios instead, listening to descriptions of what the visual watchers were seeing. The moon, which had been a constant presence in the night sky for all of human history, a source of myths and poems and calendar calculations, was about to receive visitors from Earth, and a considerable fraction of Earth's population wanted to be aware of the moment when that visitation began. But before the watching could begin in earnest, before the fire and the rising and the long coast toward the moon, there was breakfast at 4 o'clock in the morning, while most of that million-person crowd was still sleeping in cars or tents or on blankets spread beneath the subtropical stars. 3 men sat down to eat steak and eggs. Their names were Neil Armstrong, Edwin Aldrin, and Michael Collins, though Edwin Aldrin had been called Buzz for so long that the nickname had essentially become his name. And these 3 men were about to attempt something that required their bodies and minds to be as prepared as human bodies and minds can be prepared for the unknown. The meal of steak and eggs before a spaceflight was a tradition by this point, having been started by Alan Shepard before his Mercury flight in 1961. And traditions matter to people who are about to do dangerous things. providing a sense of continuity and routine that can be steadying when nothing else about the day will be routine at all. The steak provided protein, and the eggs provided more protein. And together, they constituted a meal that was high in energy and low in residue, which is a polite way of saying that it would not necessitate uncomfortable bodily functions during the many hours when such functions would be difficult to manage. The three men ate in the crew quarters at Kennedy Space Center, a building that looked ordinary from the outside, institutional in that way that government buildings often are, and yet inside it contained rooms where human beings prepared to leave the planet. They had slept in narrow beds the night before, or had attempted to sleep, which is not always the same thing, and now they were eating and would soon be suiting up and would then be transported to the launch pad, each step bringing them closer to the moment of departure. A white transport van carried them from the crew quarters to Launch Complex 39A, covering the distance of several miles at a pace that was neither rushed nor leisurely, simply the pace at which one travels when one is going somewhere important, but there is still time. Still, these last few minutes in which to look out the window at the familiar landscape of Earth, the scrub palms and the industrial buildings and the security fences and the roads that led to so many ordinary destinations that were not the moon. The van was called the Astrovan, though some simply called it the transfer van, and it served the humble purpose of getting astronauts from one building to another while keeping them reasonably isolated from the germs and well-wishes of the outside world. Through the windows, Armstrong and Aldrin and Collins could see glimpses of the crowds that had gathered, all those people who had come to watch them leave, and perhaps they waved, or perhaps they simply looked, carrying with them whatever private thoughts accompany such a journey. And then there was the rocket itself, visible from miles away, standing at pad 39A like something from a dream that had somehow become solid and real. The Saturn V was 363 feet tall, which is approximately 111 meters, making it taller than the Statue of Liberty and roughly equivalent to a 36-story building, though such comparisons only approximate the experience of standing near it and looking up and up and up to where its pointed tip seemed to touch the sky it was about to enter. It was painted white, mostly, with black markings, and on its sides the letters USA were written in a blue so dark it was almost black, large enough to be read from a great distance, declaring to anyone watching from far away or very far away indeed exactly who had built this impossible tower and who was sending it skyward. Frost had formed on portions of the rocket's surface, a delicate white coating that seemed almost decorative but was in fact a consequence of what waited inside. The first stage of the Saturn V held liquid oxygen, which must be kept at temperatures far below freezing to remain in liquid form, approximately -297 degrees Fahrenheit or -183 degrees Celsius, cold enough that the air around it surrendered its moisture in surrender, ice crystals forming on the metal skin and then slowly sliding downward as gravity and gentle melting did their patient work. This frost gave the rocket an ethereal quality, as though it were not entirely of this world even before it left, already halfway to somewhere else, already belonging more to the realm of the extraordinary than the ordinary. The liquid oxygen would combine with kerosene in the first stage, and with liquid hydrogen in the upper stages. And when ignited, these combinations would produce thrust sufficient to lift 6.5 million pounds off the surface of the Earth, which is the weight of the entire rocket when fully fueled. A weight almost impossible to comprehend until you stand near it and feel your own smallness in comparison. All of that thrust would be generated in the service of pushing 3 men in a small capsule toward a destination that humans had been looking at for 200,000 years or more, ever since the first human beings tilted their heads back and noticed that pale disk in the night sky and wondered what it was. The morning wore on, the clock counting down the minutes and seconds. And all across Florida and all across the world, people waited with a patience that felt almost meditative, a collective holding of breath. Some of them understood the technical details of what was about to happen, the precise choreography of stages separating and engines igniting and trajectories calculated to carry the spacecraft into lunar orbit, while others understood only that something important was occurring, something that felt like it mattered, even if they could not have explained exactly why. The children in the crowd asked their parents questions, and the parents answered as best they could, explaining rockets and the moon and the vacuum of space, or admitting that they did not fully understand it themselves, but that understanding was not required for witnessing. The sun continued its own trajectory across the Florida sky, indifferent to human schedules, and the clouds drifted, and the humidity pressed down on everyone like a gentle hand, and the smell of sunscreen and anticipation remained. That combination of the ordinary and the unprecedented that marked this particular morning as different from all other mornings. It was still, in most ways, a typical summer day in Florida, with typical summer weather and typical summer activities available to anyone who wanted them, beaches to swim at and shops to visit and meals to eat. But layered over that typical day was something else entirely, a sense of being present at a hinge point in history, a moment when the world was about to change in a way that could not be unchanged. And so they waited, the million people along the Florida coast and the 600 million people watching from further away, all of them connected by their attention to a single point on the map. A single moment approaching on the clock. The Saturn V stood patient and frosted in the morning light, and inside it, climbing through a series of structures to reach the command module at the very top, 3 men in spacesuits made their way to their seats, where they would lie on their backs and watch the instrument panels and feel the vibrations of a machine preparing to wake. The pale blue of the Florida sky seemed to promise nothing more than another day, another sequence of hours to be lived through and then remembered or forgotten. But everyone knew that this particular day carried something else within it, a seed that was about to crack open and grow into something unprecedented, a journey outward that would change forever how human beings thought about their place among the stars. Long before any human hand could reach toward the sky with purpose, long before the mathematics existed to chart a course beyond our atmosphere, there was simply the moon, hanging in the darkness above our ancestors, and they watched it with the same quiet wonder that still touches us today when we happen to glance upward on a clear evening. The moon was humanity's first clock, its first calendar, its first companion in the vast and silent night, and for 10,000 years or more, we have traced its phases, named its shadows, and dreamed, in our patient and particular way, of somehow crossing the distance between our world and that pale, luminous face suspended in the heavens above us. In the green and rolling lands of Ireland, in a place called Noath in County Meath, there stands a great passage tomb that was ancient when the pyramids were young, a structure built some 5,000 years ago by people whose names we shall never know, whose language has been lost to time, whose daily concerns and quiet hopes have dissolved into the deep past like morning mist over the River Boyne. And yet, carved into the curbstones that encircle this monument, there are markings that some researchers believe may represent the earliest known maps of the lunar surface. Careful etchings that seem to correspond to the Maria, those dark basaltic plains that we can see with our unaided eyes when the moon is full. Whether these ancient artists truly intended to map the moon, or whether they were recording something else entirely, something we cannot now recover or understand, remains a matter of gentle scholarly debate. But the possibility alone is enough to remind us that the impulse to study and to know our celestial neighbor is as old as civilization itself, older perhaps than writing, older than the wheel, reaching back into a time when the only tools available were stone and patience and the slow accumulation of nights spent watching the sky. For most of human history, the moon remained what it had always been, a light in the darkness, a marker of seasons, a subject for poetry and myth and the quiet speculation of philosophers who wondered what substance it might be made of, whether it was a perfect sphere or something rougher, whether it harbored life or water or cities of beings unlike ourselves. The Greek philosopher Anaxagoras, who lived some 2,500 years ago, suggested that the moon was a rocky body, much like the Earth, and for this and other teachings that challenged the conventional wisdom of his time, he was accused of impiety and forced into exile. A reminder that even the gentlest scientific curiosity has not always been welcomed by those who prefer their mysteries to remain mysterious. Then, in the year 1609, an Italian mathematician and astronomer named Galileo Galilei turned a new instrument toward the night sky, a device that had been developed by Dutch spectacle makers for looking at distant objects on Earth, and which Galileo had refined and improved until it could magnify images by a factor of 20. What he saw through this telescope, this simple arrangement of lenses in a tube, changed humanity's understanding of the cosmos in ways that are difficult to overstate. Though we shall not attempt drama here, only the quiet recounting of facts. Galileo observed that the moon was not the smooth and perfect sphere that ancient philosophy had supposed, but rather a world of mountains and craters, of shadows that shifted as the lunar day progressed, of terrain that was, in its own way, not so very different from the landscapes of Earth. He made careful sketches of what he saw, drawings that showed the terminator, that line between lunar day and lunar night, creeping across a surface marked by circular depressions and elevated regions. And these sketches, rendered in brown ink on paper that has survived to our own time, represent the first detailed scientific observations of another world. The first attempt to record not what we imagined the moon to be, but what it actually appeared to be when examined with care and patience and a willingness to see clearly. Around this same time, a German astronomer named Johannes Kepler, who had done so much to establish the mathematical laws governing planetary motion, allowed himself a different kind of lunar contemplation, one that we might today call science fiction, though that term would not be coined for centuries yet. In 1608, Kepler completed a manuscript called Somnium, which is the Latin word for dream, a strange and wonderful narrative in which a young Icelandic student is transported to the moon through the intervention of a demon, a spirit summoned by his mother, who is described, with perhaps uncomfortable candor, as a practitioner of folk magic. Upon reaching the moon, the traveler finds a world of extremes, of burning days and freezing nights, of creatures adapted to conditions utterly unlike those of Earth. And while Kepler's science was necessarily speculative, constrained by the limited knowledge of his era, his imagination anticipated many of the challenges that lunar travelers would eventually face. The vast temperature swings, the airlessness, the alien quality of a place that is close enough to see but far enough to be utterly foreign. Kepler did not live to see his Somnium published, and the work appeared only after his death, accompanied by extensive footnotes in which he attempted to distinguish his fanciful narrative from his serious scientific beliefs, perhaps worried that readers might confuse the two, or perhaps simply unable to resist explaining his own jokes. More than 2 centuries passed, centuries in which the telescope improved and the moon revealed more and more of its secrets to patient observers, centuries in which the mathematics of motion and gravity were refined until the paths of celestial bodies could be predicted with remarkable precision. And then, in 1865, a French novelist named Jules Verne published a book that would capture the imagination of readers around the world and anticipate, with eerie accuracy, certain details of the actual moon missions that lay more than a century in the future. The novel was called De la Terre à la Lune, or From the Earth to the Moon, and it told the story of a group of American artillery enthusiasts who, finding themselves at loose ends after the conclusion of the Civil War, decide to channel their expertise into a grand project, the construction of an enormous cannon capable of launching a projectile and eventually human passengers to the moon. Verne placed his launch site in Florida, not very far from where Cape Canaveral would eventually rise from the coastal scrubland, and he sent 3 travelers on the journey, the same number that would crew the Apollo missions. And while his method of propulsion, a giant gun called the Columbiad, would have subjected any passengers to fatal accelerations, and while his travelers do not actually land on the moon but merely orbit it before returning to Earth, the parallels between his fiction and the eventual reality are numerous enough to have occasioned much comment over the years, and to have earned Verne a reputation as a prophet of the space age, a man who saw the future clearly, even if he could not quite imagine all its details. The 19th century gave way to the 20th, and the dreamers began to do mathematics, began to work out the actual requirements for leaving Earth's gravity and reaching another world. In Russia, a largely self-taught scientist named Konstantin Tsiolkovsky, who had been deaf since childhood and who worked for much of his life as a provincial schoolteacher in towns far from the great centers of learning, published in 1903 a paper that contained what we now call the Tsiolkovsky rocket equation, a mathematical relationship describing how the velocity of a rocket depends on the exhaust velocity of its propellant and the ratio of the rocket's initial mass to its final mass after the propellant has been expended. This equation, which can be written in a single line of mathematical notation, is at once elegant and sobering, for it reveals just how difficult space travel truly is. How much of a rocket's mass must be given over to fuel, how unforgiving the physics of propulsion can be. And yet, it also pointed the way forward, showing that rocket-powered spaceflight was not a violation of any natural law, merely a formidable engineering challenge, one that could, in principle, be overcome by human ingenuity and sufficient resources. In the United States, a quiet and often sickly physics professor named Robert Goddard was thinking along similar lines, and doing more than thinking, actually building and testing the devices that theory suggested should work. On the 16th of March, 1926, in a snow-covered field on a farm in Auburn, Massachusetts, Goddard launched the world's first liquid-fueled rocket, a spindly contraption of pipes and tanks that rose 41 feet into the cold New England air and flew for about 2.5 seconds before crashing into a frozen cabbage patch some 180 feet from its launch point. The flight was brief and the altitude modest, but the principle had been demonstrated, the concept proven, and Goddard would spend the rest of his life refining his rockets, moving his experiments to the more accommodating climate of New Mexico, enduring the skepticism of colleagues and the occasional ridicule of newspapers that found his dreams of reaching the moon to be excellent material for mockery. He died in 1945, more than 2 decades before the moon landing, and never saw the vindication of his work. But his patents and his meticulous engineering notes would influence everyone who came after him, and he is remembered today, gently and without excessive fanfare, as one of the founding figures of spaceflight. In Germany, another rocket enthusiast named Hermann Oberth was pursuing similar research and inspiring a generation of young engineers who would eventually make the dreams of Tsiolkovsky and Goddard and Verne a reality. Among Oberth's admirers was a teenager named Wernher von Braun, who read Oberth's writings on rocket propulsion and became, from that moment forward, consumed by the vision of human spaceflight, a vision that would shape his entire career, leading him through morally complex and troubling paths during the Second World War, and eventually to the United States, where he would become one of the principal architects of the Saturn V rocket that carried the Apollo astronauts to the moon. The line from Oberth to von Braun to Apollo is direct and traceable, a chain of influence and inspiration that connects the theoretical speculations of the early 20th century to the enormous rocket engines that would eventually shake the Florida coastline with their thunder. And as the 1950s dawned, and rockets grew larger and more capable, and the idea of spaceflight began to seem less like fantasy and more like an approaching reality, ordinary people began to imagine themselves as participants in the adventure. In New York City, the Hayden Planetarium, that great dome of stars in Manhattan, began accepting reservations for future trips to the moon, a publicity gesture that captured the public imagination more thoroughly than anyone had anticipated. And by the time the program ended, more than 25,000 people had added their names to the waiting list. 25,000 expressions of hope and curiosity and willingness to journey into the unknown, even if the journey existed, at that point, only in the realm of possibility and optimism. All of this, the ancient stone carvings and the Renaissance telescopes, the mathematical equations, and the small rockets rising from snowy fields, the science fiction novels, and the planetarium reservations. All of this was the long, slow, patient accumulation of human longing and human effort, the gradual transformation of a dream into a plan, and a plan into a capability. 10,000 years of watching the moon had led, through countless intermediate steps, each one small but necessary, to a summer night in 1969, when 3 men would sit atop a rocket in Florida and wait for the moment when all that ancient wondering would finally, quietly, become reality. And that moment was now very close indeed. On the morning of July 16th, 1969, the sun rose over the Florida coastline and cast its early light across the wetlands and waterways surrounding Cape Kennedy, where a great white rocket stood waiting on Pad 39A, wreathed in wisps of vapor that curled slowly upward into the warm summer air. The Saturn V had been standing there for some time already, having been rolled out to the launch site many weeks before, and in those final hours before flight, it seemed almost patient, almost still, like some enormous sculpture placed there by careful hands and left to contemplate the sky it would soon enter. The liquid oxygen that filled its tanks was so cold that it caused moisture in the humid Florida atmosphere to condense and drift away in pale streamers, giving the rocket an appearance of breathing, of quiet exhalation, as though it were a living thing preparing itself for tremendous exertion. In the firing room of the Launch Control Center, which stood some 3.5 miles from the pad, hundreds of engineers and technicians sat before their consoles in long rows, each person responsible for monitoring some particular system, some specific set of readings that would tell them whether all was well with the great machine outside. The launch director and his team had been at work since the small hours of the morning, checking and rechecking every valve, every connection, every measurement that could be checked, and now, as the clock moved closer to the scheduled moment of departure, a certain focused calm settled over the room. Among those present was Jack King, whose voice would carry the final moments of the countdown out to the world, speaking into a microphone with the steady, measured tone of a man who had done this work before and understood that clarity and precision mattered more than excitement. The 3 astronauts had been awake since well before dawn, eating a quiet breakfast of steak and eggs, a meal that had become something of a tradition for crews about to fly. And then they had suited up in their bulky pressure garments and ridden the elevator up the launch tower to enter the spacecraft that sat atop the rocket, more than 300 feet above the Florida sand. Neil Armstrong took his place in the left couch, Buzz Aldrin in the right, and Michael Collins in the center. And once they were strapped in and connected to the spacecraft's systems, there was little for them to do but wait and listen as the countdown proceeded through its final minutes, each announcement bringing them closer to the moment when the rocket would come alive beneath them. At approximately 9:32 in the morning, Eastern Daylight Time, the count reached 0, and the 5 F1 engines at the base of the Saturn V's first stage ignited in a carefully orchestrated sequence designed to bring them up to full power without tearing the rocket apart. Each of those 5 engines was a marvel of engineering in its own right, standing nearly 19 feet tall and weighing more than 18,000 pounds. And together they generated approximately 7.5 million pounds of thrust, which is a number so large that it becomes difficult to comprehend in ordinary terms. Perhaps it helps to know that each engine consumed propellant at a rate of roughly 3 tons per second, drawing in vast quantities of refined kerosene and liquid oxygen and combining them in combustion chambers where temperatures exceeded 6,000 degrees Fahrenheit, transforming chemical potential into the raw force that would lift all 6.5 million pounds of rocket and fuel and spacecraft off the ground and send it climbing toward the heavens. The sound of those engines reached the spectators gathered along the beaches and causeways and viewing areas several seconds after ignition, because sound travels so much more slowly than light. And when it arrived, it was not so much heard as felt. A deep physical rumble that seemed to pass through the body and resonate in the chest. Even 3 miles away, where the launch control building stood, the vibrations could be sensed, a trembling in the structure itself that reminded everyone present of the tremendous forces being unleashed outside. Some observers later described the experience as overwhelming, not painful exactly, but all-encompassing, as though the entire world had begun to hum at a frequency too low for the ears to fully process, but too powerful for the body to ignore. The rocket rose slowly at first, as rockets always do, because in those initial moments, the thrust is only barely greater than the weight it must overcome, and the Saturn V climbed away from the launch tower with a kind of ponderous dignity, trailing a column of brilliant flame that seemed almost as long as the rocket itself. Gradually, imperceptibly at first, and then more noticeably, the vehicle gained speed as it burned through its fuel and became lighter with each passing second, and the watchers below saw it arc gracefully out over the Atlantic Ocean, growing smaller and fainter against the blue morning sky until it was just a bright point of light, and then not even that. Inside the spacecraft, the crew experienced the launch as a sustained and building pressure, a steady acceleration that pushed them back into their couches with increasing force as the rocket climbed higher and the air grew thinner. The ride was rougher than one might expect, with considerable vibration and noise, though the astronauts had trained for these sensations many times and knew what to anticipate. Through the small windows, they could see the sky darkening as they rose through the atmosphere, the familiar blue giving way first to a deeper shade and then to something approaching black. And they knew that they were leaving the sheltering blanket of air that surrounds our planet and entering a realm where different rules apply. 2 minutes and 42 seconds after liftoff, at an altitude of approximately 42 miles above the Earth's surface, the first stage exhausted its fuel and separated from the rest of the vehicle. This event, called staging, was accomplished through a sequence of small explosive charges that severed the connections between the stages and pushed them apart. And for a brief moment, the crew experienced the strange sensation of weightlessness before the 5J2 engines of the second stage, known as the S2, ignited and acceleration resumed. The spent first stage fell away behind them, tumbling slowly back toward the ocean far below, its work complete, its purpose fulfilled. The second stage burned for approximately 6 minutes, carrying the spacecraft higher and faster, and when it too was exhausted, it separated in turn, leaving only the SIVB third stage to complete the work of reaching orbit. This final stage, powered by a single J2 engine, burned for about 2.5 minutes before shutting down. having placed the spacecraft into a temporary parking orbit around the Earth at a velocity of approximately 17,400 miles per hour. At this speed, the astronauts circled the planet once every 90 minutes or so, watching the continents and oceans drift past below them with a serenity that seemed almost impossible given the violence of the launch they had just experienced. Michael Collins, who served as the command module pilot on this mission and who would later remain in lunar orbit while his companions descended to the surface, had a way of describing the experience of spaceflight that captured something of its quiet strangeness. He spoke of the magnificent desolation of the void, the profound emptiness that surrounds a spacecraft once it leaves the protective embrace of Earth's atmosphere. And though those words would become most associated with the lunar surface itself, they applied equally well to the experience of coasting through the darkness between worlds, surrounded by stars that did not twinkle because there was no atmosphere to make them shimmer. For about 2 hours and 44 minutes, the spacecraft remained in Earth orbit, during which time the crew and the ground controllers verified that all systems were functioning properly and that it was safe to proceed with the next phase of the mission. This period of checking and preparation was necessary because the next maneuver, called the Translunar Injection Burn, would commit the spacecraft to its journey to the Moon, and once that burn was complete, there would be no easy way to return quickly to Earth. Everything had to be right. Every system had to be working. Every calculation had to be confirmed, because the consequences of error at this point would be severe. When the moment came, the SIVB third stage reignited its engine for approximately 5 minutes and 50 seconds, adding nearly 7,000 miles per hour to the spacecraft's velocity and sending it arcing away from Earth on a long, curving trajectory toward the Moon. The Moon at that moment was not where the spacecraft was pointed, because the spacecraft was aimed at where the Moon would be in 3 days' time. The two objects moving through space in a kind of slow-motion dance that the mission planners had choreographed with exquisite precision. Ahead of the astronauts lay a journey of approximately 240,000 miles, a distance so vast that it would take them the better part of 3 days to traverse, even at speeds that no human vehicle had ever achieved before. Once the translunar injection burn was complete and the spacecraft was safely on its way, the crew had time to settle into the routines that would govern their lives for the duration of the voyage. The interior of the command module was not spacious by any ordinary standard, being roughly equivalent in volume to the interior of a large automobile, but it was home for the time being, and the astronauts adapted to its confines with the practiced ease of professionals who had trained for this moment for years. One of the essential tasks during the coast to the Moon was the slow rotation of the spacecraft, known informally as the barbecue roll, or more formally as passive thermal control. The purpose of this maneuver was to distribute the intense heat of the sun evenly across the spacecraft's surface, preventing one side from becoming dangerously hot while the other grew dangerously cold. In the vacuum of space, there is no air to carry heat away by convection, and without the barbecue roll, the sun-facing side of the spacecraft would absorb enormous amounts of thermal energy, while the shadowed side radiated its heat away into the void, creating temperature differences that could damage equipment or make the cabin uncomfortable for the crew. By rotating slowly, at a rate of about 1 revolution per hour, the spacecraft exposed all of its surfaces to the sun in turn, maintaining a relatively even temperature throughout. As they rotated gently through the darkness, with the blue disk of Earth growing smaller behind them and the grey sphere of the Moon waiting ahead, the crew took their first meal of the voyage, a modest repast of beef and vegetables prepared in the form of freeze-dried packets that could be reconstituted with hot water from the spacecraft's fuel cells. Eating in weightlessness required some adjustment, as food and water had a tendency to float away if not carefully managed. But the astronauts had practiced these procedures and knew how to cope with the peculiarities of their environment. They ate slowly and carefully, watching the Earth drift past the windows as they turned, and reflected perhaps on the extraordinary circumstances that had brought them to this place, coasting through the void at thousands of miles per hour, bound for a world that no human being had ever touched. And so the great ship sailed outward, away from all that was familiar, away from the blue curve of Earth that had cradled every human being who had ever lived, and the three men settled into what would become the longest and strangest journey of their lives. A journey of nearly 250,000 miles through the most profound emptiness imaginable. A void so complete and so silent that the mind struggles to comprehend it even now. Decades later, when we speak of it in soft and measured tones, the coast to the Moon, as it was called, lasted approximately 3 days, and during those 3 days, the spacecraft Columbia moved through space at tremendous speed, while appearing, to those inside, to move not at all. For there was nothing outside the windows to provide any sense of motion, no clouds rushing past, no landscape scrolling beneath, no sensation of wind or friction or resistance of any kind. Just the unchanging blackness of the cosmos, decorated with the cold and steady light of uncountable stars. Stars that did not twinkle as they do when seen through Earth's atmosphere, but which burned with a hard and unwavering brilliance that spoke to their true nature as distant suns. The silence of space travel is not the silence we know on Earth, not the silence of a quiet room or a still forest, but something far more absolute. A silence born from the complete absence of any medium through which sound might travel. And while the interior of the spacecraft hummed with the soft sounds of machinery and the whisper of air circulation, the universe beyond those thin aluminum walls was utterly and perfectly mute, a silence so vast and so ancient that it predated the formation of the Earth itself, a silence that had reigned in that particular region of space for billions of years and would continue to reign long after the small vessel had passed through on its way to the Moon. Navigation during this long coast required a method that would have been recognizable to sailors from centuries past, for the Apollo guidance computer, though revolutionary for its time, needed to be periodically updated with precise positional data. And this data came from the careful observation of the stars, those same stars that had guided mariners across the trackless oceans of Earth, now serving to guide astronauts across the trackless ocean of space. And the method involved a small optical instrument called a sextant, mounted in the command module, through which the navigator could sight upon specific celestial bodies and measure their angles relative to the spacecraft's orientation. There were 37 stars programmed into the guidance computer's memory, 37 carefully selected points of light scattered across the celestial sphere, each one chosen for its brightness and its position relative to the others, each one given a number and a name. And these stars bore the ancient names that astronomers had used for centuries. Names like Rigel and Canopus and Arcturus and Vega. Names that carried within them the weight of human history and human curiosity. Names first spoken by observers who could never have imagined that one day their careful cataloguing of the heavens would help to steer a ship toward the moon. The astronaut would float to the navigation station, peer through the sextant's eyepiece, locate one of the 37 stars, align the instrument just so, and press a button to mark the angle. And this information would flow into the computer, which would compare the observed positions with its calculated expectations and adjust its understanding of where the spacecraft was and where it was going. A marriage of the ancient art of celestial navigation with the emerging science of digital computation. Tradition and innovation working together in the silence between worlds. The temperature extremes experienced during the coast were remarkable in their severity, for the spacecraft was exposed to conditions that no earthly environment could match. Conditions born from the absence of atmosphere and the unfiltered radiation of the sun. And on the side of the spacecraft facing the sun, the temperature climbed to approximately 280 degrees Fahrenheit. Hot enough to boil water, hot enough to make metal uncomfortably warm to the touch. While on the shadow side, the temperature plunged to approximately 280 degrees below 0 Fahrenheit, cold enough to freeze almost any substance known to chemistry, cold enough to make metal brittle and fragile. To manage these extremes, the spacecraft performed what was called the barbecue roll, a slow and continuous rotation about its long axis, spinning gently like a rotisserie chicken. And this rotation ensured that no single side of the spacecraft was exposed to the sun's heat or the void's cold for too long, distributing the thermal load evenly around the vehicle's circumference, keeping the interior temperatures within the range that human beings and their machinery could tolerate. A simple and elegant solution to a problem that might otherwise have proved insurmountable. Sleep, during these 3 days, proved difficult for all 3 astronauts, for the human body is accustomed to the rhythms of earthly life, to the rising and setting of the sun, to the familiar pull of gravity that tells us which way is down. And in the spacecraft, none of these cues existed in their normal form. The sun did not set so much as it moved around the windows as the spacecraft rotated. Gravity was essentially absent, and the constant hum of machinery and the awareness of the enormous responsibility resting upon their shoulders made true rest elusive. The crew attempted to maintain a sleep schedule coordinated with mission control in Houston, where flight controllers worked in shifts around the clock, monitoring every aspect of the spacecraft's systems. But the astronauts found themselves sleeping in fragments, catching an hour here and 2 hours there, never quite achieving the deep and restorative sleep that the body craves. And Commander Neil Armstrong, who would bear the greatest burden of responsibility when the time came to land on the moon, managed only about 5 hours of sleep during the rest period before the landing attempt. 5 hours of fitful rest before undertaking the most demanding piloting task ever attempted by a human being. Michael Collins later reflected on the strange nature of sleep in space. The way the body would float if not secured. The way dreams seemed different in the absence of gravity. The way waking brought not the familiar sensation of lying in bed, but rather the disorienting awareness of floating in a small metal chamber somewhere between worlds. And these observations, recorded in his journal and his later writings, provide a window into the psychological reality of spaceflight, a reality that was genuinely new to human experience. On July 19th, 3 days after leaving Earth, the spacecraft approached the Moon, and the time had come for a critical maneuver, one that would determine whether the mission continued or ended. For the spacecraft was traveling at tremendous speed, fast enough to sweep past the Moon and continue on into the void of deep space if nothing were done to slow it down. And so the service module's main engine needed to fire at precisely the right moment and for precisely the right duration to capture the spacecraft into lunar orbit. This maneuver was called lunar orbit insertion, and it required the engine to fire for approximately 6 minutes. 6 minutes during which the astronauts felt the gentle but steady push of deceleration. 6 minutes during which the spacecraft's velocity decreased by just enough to bend its trajectory into an ellipse around the Moon, rather than a hyperbola that would carry it away forever. And this firing occurred while the spacecraft was behind the Moon, out of contact with Earth, invisible to the tracking stations and the flight controllers, who could do nothing but wait and hope. When the spacecraft emerged from behind the Moon and radio contact was re-established, the telemetry told the story. The engine had performed flawlessly. The orbital parameters were within acceptable limits. Apollo 11 was now circling the Moon at an altitude of approximately 60 miles, close enough to see the surface in remarkable detail, close enough to begin the final preparations for the landing attempt that would come the following day. Michael Collins, looking out the window as the spacecraft settled into its orbit, was struck by the appearance of the lunar surface, and he described what he saw as looking like plaster of Paris grey, a world without colour in the familiar sense, a world of subtle shades of grey and white and charcoal, a world that appeared ancient and battered and utterly lifeless, covered with craters upon craters, a record of billions of years of cosmic bombardment written in the scarred and pockmarked face of Earth's only natural satellite. The Moon, seen from 60 miles above its surface, was overwhelming in its presence, filling the windows of the spacecraft with its bulk, its horizon curving away in all directions, its surface rolling past below at approximately 3,600 miles per hour. And yet there was no sensation of speed, only the silent gliding of the spacecraft above this alien landscape. And the astronauts found themselves gazing down at terrain that no human eyes had ever seen from such a vantage point, studying the shapes of mountains and the depths of craters and the vast dark plains that the ancient astronomers had mistaken for seas. Each orbit took approximately 2 hours to complete, and for roughly 45 minutes of each orbit, the spacecraft passed behind the Moon relative to Earth, and during these 45-minute periods, all radio communication was impossible. For electromagnetic radiation travels in straight lines and cannot bend around obstacles, and the bulk of the Moon stood between the spacecraft and the antennas of Earth, creating a zone of absolute radio silence, a zone in which the astronauts were truly alone, cut off from the voices that had accompanied them since launch, left with only their own thoughts and the whispered sounds of their machinery. These communication blackouts became a regular feature of the lunar orbital phase, a rhythm of contact and silence, of connection and isolation. And the astronauts learned to time their communications accordingly, to complete their important conversations before loss of signal, and to prepare their reports for the moment when signal was reacquired. And Mission Control learned to wait through those 45-minute gaps with patience and perhaps with a certain amount of anxiety that they took care not to show. The landing site had been chosen with extraordinary care, after years of study and debate and analysis. For the first crewed landing on the Moon could not afford to fail due to poor site selection, and the location needed to meet multiple criteria. It needed to be smooth enough to provide a safe surface for landing. It needed to be near the lunar equator to minimize the fuel required to reach it. It needed to be at a location where the sun angle would be appropriate for visibility during the landing. And it needed to be in a region that had been photographed and mapped in sufficient detail to permit accurate navigation. Mare Tranquillitatis, the Sea of Tranquility, met all of these criteria. A vast, dark plain in the Moon's northeastern quadrant. One of the lunar maria that had formed billions of years ago when ancient volcanic activity had flooded low-lying regions with basaltic lava, creating smooth and relatively flat terrain that had been studied extensively through photographs returned by the Lunar Orbiter program, unmanned spacecraft that had circled the Moon in 1966 and 1967. Sending back thousands of images that mission planners had used to identify and characterize potential landing sites. The Lunar Orbiter photographs revealed a region of gentle undulations and scattered craters, a region that appeared more forgiving than many alternatives, a region where a skilled pilot might reasonably expect to find a safe spot to set down. And the specific landing zone within Mare Tranquillitatis had been selected and studied and restudied and restudied. Its features memorized by the astronauts, its landmarks programmed into the guidance computer. Everything prepared with the meticulous attention to detail that characterized every aspect of the Apollo program. And then there was Earthrise, perhaps the most unexpected experience of the journey, the moment when the spacecraft rounded the limb of the Moon and the Earth rose above the lunar horizon, a small blue marble suspended in the blackness of space, delicate and luminous and impossibly beautiful, appearing so fragile that it seemed a single careless gesture might shatter it. And the astronauts found themselves reaching for their cameras, capturing images that would become among the most significant photographs ever made. The Earth from lunar orbit appeared small enough to cover with an outstretched thumb. A world that contained every human being except the 3 in the spacecraft. A world that contained every city and every forest and every ocean and every mountain. Every war and every work of art and every act of kindness, all reduced to a blue and white sphere no larger than a marble held at arm's length. And this perspective, so humbling and so profound, would stay with the astronauts for the rest of their lives. They photographed their home repeatedly as it rose above the Moon's dead horizon, recording the sight for those who would never make this journey, documenting this new view of Earth for future generations. And in those photographs, we can see the planet as it appeared on those July days in 1969. The cloud patterns over the Pacific, the brown and green shapes of continents, the blue that speaks of water and atmosphere and life. All of it floating in a darkness that contains nothing else for hundreds of thousands of miles. The Sea of Tranquility awaited below, grey and patient, as old as the solar system itself, and the crew of Apollo 11 circled above it in their small spacecraft, preparing for what would come next, checking their systems, reviewing their procedures, trying to rest, though rest would not come easily, and the moon turned beneath them in its eternal silence, indifferent to their presence, indifferent to their hopes, a world that had waited 4 billion years for this moment and would wait 4 billion more after they had gone. On the 20th of July, in the year 1969, at approximately 13 minutes past 1 in the afternoon, Eastern Daylight Time, the spacecraft Columbia continued its patient orbit around the moon, carrying within it 3 human beings who had traveled further from their home than any others in the long history of their species. Michael Collins remained aboard the command module, tending to the systems that would eventually carry all 3 astronauts back toward Earth, while Neil Armstrong and Edwin Aldrin prepared themselves for a journey that would take them even further still, down toward the grey and ancient surface that rolled beneath them in the blackness of space. The lunar module, which the crew had named Eagle, remained attached to Columbia as it had been throughout the long transit from Earth. The 2 spacecraft joined together like the segments of some delicate mechanical insect drifting through the void. The separation of these 2 vehicles was a procedure that had been rehearsed many times, both in simulators on Earth and during the Apollo 10 mission that had tested nearly every aspect of this very descent without actually touching down upon the lunar surface. At 46 minutes past 1 in the afternoon, the latches that held Eagle to Columbia released their grip, and the lunar module began to drift gently away from its companion spacecraft, beginning its own distinct trajectory toward the surface below. Collins, watching from the windows of Columbia, could see the spindly legs of the Eagle extending outward, the golden foil that wrapped its descent stage glinting in the unfiltered sunlight, and he spoke to his crewmates through the radio link that would maintain their connection throughout the hours to come. The 2 spacecraft moved apart with a slowness that seemed almost contemplative, as though the vehicles themselves understood the significance of this parting. And within a short time, Eagle had positioned itself with its descent engine pointed in the direction of travel, ready to begin the powered descent that would carry it down through the 50,000 feet of empty space between its current altitude and the surface of the moon. The powered descent initiation, which the flight controllers referred to simply as PDI, began with the ignition of the descent engine at an altitude of approximately 50,000 feet above the lunar surface. This engine, which had been designed and built with extraordinary care by the engineers of the Grumman Aircraft Engineering Corporation, burned a combination of hydrazine and nitrogen tetroxide, propellants that ignited spontaneously upon contact with one another and thus required no spark or flame to begin their combustion. The engine came to life with a steadiness that the astronauts could feel as a gentle pressure pushing them back into their harnesses, and the lunar module began to slow its forward velocity while simultaneously beginning its long descent toward the landing site in the southwestern portion of the Sea of Tranquility. The guidance computer aboard Eagle, a machine that represented the most advanced digital technology of its era, despite possessing less computational power than the simplest electronic devices of later generations, worked continuously to calculate the spacecraft's position, velocity, and the precise engine burns required to deliver it to the designated landing coordinates. This computer, built by the engineers at the Massachusetts Institute of Technology's Instrumentation Laboratory, monitored data from the spacecraft's radar systems, its inertial measurement unit, and numerous other sensors, performing thousands of calculations each second to keep the descent on its proper trajectory. At an altitude of approximately 33,500 feet above the lunar surface, with the Eagle continuing its descent through the vacuum above the grey plains below, the computer began to display an alarm that the astronauts had not expected to encounter during this critical phase of their mission. The alarm appeared as a series of numbers on the display and keyboard unit, reading 1202, and it indicated that the computer was receiving more data than it could process in the time allotted to each computational cycle. The source of this overload was the rendezvous radar system, which had been left in a particular switch position that caused it to flood the computer with information that was not needed during the descent phase, but which the computer nonetheless felt obligated to process. In the Mission Operations Control Room in Houston, Texas, a young engineer named Steve Bales sat at his console in the front row of flight controllers, monitoring the performance of the guidance and navigation systems aboard the Eagle. Bales was 26 years old at the time, a native of the small town of Fremont in the state of Iowa, and he had spent countless hours studying the behavior of the guidance computer and the various alarm codes it might generate under different circumstances. When the 122 alarm appeared on his display, Bales had only seconds to determine whether this alarm indicated a serious malfunction that would require the astronauts to abort their landing attempt, or whether it was a less critical issue that could be safely ignored while the descent continued. The flight rules that governed the mission were clear in their requirements, stating that any computer alarm during the descent phase should be treated as a potential abort condition unless the flight controllers could quickly determine otherwise. Bales consulted briefly with a colleague named Jack Garman, who sat in a back room of the control center with a handwritten list of computer alarm codes and their meanings. And Garman confirmed that the 122 alarm was what they called an executive overflow, a condition in which the computer was shedding lower priority tasks in order to focus its limited resources on the most critical calculations required for the landing. Within a span of seconds, that must have felt considerably longer to all involved. Bales made his determination and spoke the single word that would allow the descent to continue. A simple and unhesitating affirmation that the alarm could be safely disregarded and that the Eagle should press on toward the lunar surface. The computer alarm appeared several more times during the descent, each occurrence requiring the flight controllers to reaffirm their confidence in the spacecraft's systems, and each time Bales and his colleagues provided the same reassuring response. The astronauts, for their part, maintained their focus on the tasks before them, trusting that the engineers on the ground would alert them to any condition that truly warranted an abort. And the lunar module continued its steady progress downward through the vacuum of space toward the landing site that grew larger in their windows with each passing moment. As the Eagle descended through an altitude of approximately 400 feet above the lunar surface, Neil Armstrong turned his attention from the guidance computer to the view outside his triangular window, and what he saw there gave him cause for concern. The computer, following its programmed trajectory with mechanical precision, was guiding the spacecraft toward an area that contained a field of boulders, some of them as large as automobiles, scattered across the surface in a pattern that would make a safe landing extremely difficult, if not impossible. Armstrong, who had spent many hours practicing manual landings in the Lunar Landing Training Vehicle back on Earth, made the decision to take control of the spacecraft from the computer and fly the final approach himself, searching for a smoother area where the Eagle could safely touch down. With his right hand on the attitude controller and his left hand on the thrust translation controller, Armstrong began to guide the lunar module across the surface, flying forward and slightly to the left, scanning the terrain below for a suitable landing spot, while Aldrin called out the altitude and velocity readings from the guidance computer. The fuel remaining in the descent stage tanks was diminishing with each passing second, and the flight controllers in Houston watched their displays with a focused intensity as the numbers counted down toward the point at which they would be required to call for an abort. At 60 seconds of fuel remaining, a flight controller named Charles Duke, who served as the capsule communicator for this phase of the mission, transmitted the fuel warning to the crew, his voice steady and measured despite the tension that filled the control room. The astronauts acknowledged the call and continued their search for a landing site, the Eagle drifting forward across the surface at a speed of roughly 20 feet per second while gradually descending toward the grey dust below. 30 seconds later, Duke transmitted another warning, indicating that only 30 seconds of fuel remained, and the tension in the control room reached its peak as the flight controllers waited to learn whether the mission would succeed or whether Armstrong would be forced to abort the landing attempt at the very last moment. What the astronauts and flight controllers did not know at that moment was that the actual fuel remaining in the tanks was slightly different from what the instruments indicated, and later analysis would reveal that the Eagle had approximately 25 seconds of fuel left when its footpads finally made contact with the lunar surface. The fuel quantity sensors aboard the spacecraft were not perfectly accurate at low fuel levels, and the propellant had a tendency to slosh about in the tanks during the final maneuvering, making precise measurement difficult. Regardless of the exact quantity remaining, the margin was extraordinarily slim, and the success of the landing depended upon Armstrong finding a suitable spot within the next few heartbeats. As the Eagle descended through the final 100 feet of its journey, the astronauts and the flight controllers in Houston began to observe a phenomenon that had never before been witnessed by human eyes: the appearance of the spacecraft's shadow upon the surface of another world. The shadow stretched out before the lunar module as it descended, elongated by the low angle of the sun, and it moved across the grey dust in a manner that seemed almost dreamlike in the silence of space. This was the first shadow ever cast upon the moon by an object created by human hands, a dark silhouette that traced the outline of the Eagle against the ancient surface below, and it provided Armstrong with a visual reference that helped him gauge his altitude and rate of descent during the final moments of the approach. The medical sensors attached to Neil Armstrong's body transmitted data back to the flight surgeons in Houston, and these readings revealed the physical toll that the landing was exacting upon the mission commander. At the beginning of the powered descent, Armstrong's heart rate had been recorded at approximately 77 beats per minute, a calm and measured rhythm that reflected his years of experience as a test pilot and his familiarity with high-stress situations. As the descent progressed and the challenges mounted, his heart rate began to climb, rising steadily through the 100 mark and continuing upward as he took manual control of the spacecraft and searched for a landing site. By the time the Eagle was approaching the lunar surface, Armstrong's heart rate had reached 150 beats per minute, a level that indicated significant physiological stress, even for a man as composed and experienced as the mission commander. At 17 minutes past 4 in the afternoon, Eastern Daylight Time, a blue light illuminated on the instrument panel of the lunar module, indicating that one of the probes extending from the footpads had made contact with the lunar surface. Aldrin called out the contact light, his voice calm and professional as it had been throughout the descent, and Armstrong immediately shut down the descent engine to prevent the exhaust from disturbing the surface beneath the spacecraft or causing the lunar module to tip over upon landing. The Eagle settled the final few feet to the surface, its legs compressing slightly to absorb the impact, and then all motion ceased as the spacecraft came to rest upon the Moon. A moment of silence followed, filled only by the quiet hum of the spacecraft's systems and the breathing of two human beings who had just become the first of their kind to land upon another celestial body. Then Armstrong's voice came across the radio link, speaking words that would be remembered for as long as human beings continued to remember their own history. A simple announcement that transformed the dreams of countless generations into accomplished fact. "Houston, Tranquility Base here," he said, his voice steady and unhurried, despite the extraordinary nature of the moment. "The Eagle has landed." In the control room in Houston, the flight controllers who had guided the mission to this point allowed themselves a moment of celebration, though the work of supporting the astronauts on the lunar surface was only beginning. Charles Duke, still serving as capsule communicator, responded to Armstrong's announcement with an acknowledgement that conveyed the relief felt by everyone in the room, noting that the transmission had been received and that a number of the controllers had been turning somewhat blue from holding their breath during the final moments of the descent. The tension that had filled the room dissipated slowly, replaced by a quiet satisfaction that came from knowing that years of effort and the work of hundreds of thousands of people had just achieved its most significant milestone. On the surface of the Moon, the Eagle sat motionless in the grey dust of the Sea of Tranquility, its spindly legs splayed outward and its golden foil glinting in the sunlight, the first human vessel ever to rest upon the surface of another world. The shadow that it cast stretched out across the ancient regolith, dark against the lighter grey of the surrounding terrain, and the astronauts within began the procedures that would prepare them for the next phase of their mission, the moment when they would open the hatch and step out onto the surface to walk where no human had ever walked before. But that moment was still several hours away, and for now, the two men simply rested in their spacecraft, breathing the recycled air and listening to the quiet sounds of their temporary home, while the Earth hung blue and white and distant in the black sky above them. After the lunar module settled onto the surface of the Sea of Tranquility, one might have expected the two astronauts to immediately open the hatch and step outside. But spaceflight has never been a pursuit that accommodates impatience, and so began a period of waiting and preparation that would stretch on for approximately 6.5 hours before either man would set foot on the lunar soil. This waiting period, though it may seem almost anticlimactic when viewed from a distance of decades, was entirely necessary and had been carefully planned into the mission timeline. For there were systems to check and reconfigure, equipment to prepare, and the simple but vital matter of ensuring that both the spacecraft and its occupants were ready for what was about to unfold. During these hours, Armstrong and Aldrin worked through their checklists with the methodical patience that characterized all aspects of the Apollo program, confirming that the ascent stage of the lunar module remained in proper working order for their eventual departure, verifying the integrity of their life support systems, and preparing the portable life support system backpacks they would wear during their time outside. The cabin of the lunar module was small, roughly the dimensions of a modest coat closet, and the two men moved carefully within this confined space as they readied themselves, taking care not to bump against switches or disturb any of the carefully arranged equipment that surrounded them. There was also a scheduled rest period during this time, though neither astronaut managed to sleep, and one can understand why, given that just beyond the thin walls of their spacecraft lay a landscape that no human being had ever walked upon. The preparations continued with the donning of their extravehicular activity suits, those cumbersome but life-sustaining garments that would protect them from the harsh conditions outside, where the temperature in direct sunlight reached approximately 280 degrees Fahrenheit, while areas in shadow plunged to equally extreme cold. Each suit was a self-contained environment, providing oxygen, temperature regulation, and protection from the vacuum, and the process of putting them on and connecting all the necessary hoses and fittings was time-consuming but unavoidable. The astronauts checked and rechecked each connection, for there would be no opportunity to correct a mistake once they had depressurized the cabin and opened the hatch to the lunar surface. At last, after all the preparations had been completed and verified, the moment approached for Neil Armstrong to begin his exit from the spacecraft. The cabin was depressurized. The atmosphere inside vented away into the vacuum of space, and the forward hatch of the lunar module was opened. This hatch, through which Armstrong would have to pass, measured approximately 32 inches square, which is to say it was quite small, and navigating through it while wearing the bulky backpack of the portable life support system required considerable care and attention. Armstrong positioned himself on the floor of the cabin, feet first, and began to back out through the hatch at 39 minutes past 10 in the evening, Eastern Daylight Time, on the 20th of July, 1969. The process of exiting was slow and deliberate, as all movements in spaceflight tend to be, and Armstrong carefully made his way through the narrow opening and onto the small platform known as the porch, which was located at the top of the ladder that descended along one of the landing legs of the lunar module. Before beginning his climb down the ladder, Armstrong reached out and pulled a D-ring that deployed a piece of equipment called the Modular Equipment Stowage Assembly, which is rather a mouthful and was therefore generally referred to simply as the Mesa. This equipment bay, mounted on the side of the descent stage, folded down when Armstrong pulled the release, and among the items it contained was a small television camera that had been specifically positioned to capture images of the historic first steps. The activation of this camera marked a remarkable moment in human communication, for it began transmitting live, black and white footage back to Earth, where an estimated 600 million people, which was roughly 1/5 of the world's population at that time, watched on television screens in their homes, in public squares, in electronics shop windows, and wherever else they could find a receiver tuned to the broadcast. The image was ghostly and somewhat unclear, the figure of the astronaut appearing as a bright shape against the darkness. But it was unmistakably real, and those who watched knew they were witnessing something that had never happened before in all of human history. The camera, mounted upside down to fit within the available space, required the receiving stations on Earth to electronically flip the image, and despite the technical limitations of the day, the footage served its purpose of allowing humanity to share in the moment. Armstrong continued his careful descent down the 9 rungs of the ladder, pausing along the way to describe what he was seeing and to test the process of climbing back up, for it was important to confirm that returning to the spacecraft would be feasible. The ladder brought him down to a footpad, one of the circular pads at the bottom of each landing leg that had distributed the weight of the spacecraft when it touched down. And from this footpad to the lunar surface itself, there remained a gap of approximately 3.5 feet, which Armstrong bridged with a small jump. This final step, dropping from the footpad to the ground, was the last physical barrier between a human being and the surface of another world. At 56 minutes past 10 in the evening, Eastern Daylight Time, Neil Armstrong placed his left foot on the moon, and as he did so, he spoke the words that would become among the most famous ever uttered, reporting that it was one small step for a man and one giant leap for mankind. Whether he said the indefinite article before the word man has been debated in the years since, as the audio transmission was somewhat unclear at that moment, but the meaning was understood by all who heard it, and the words have endured as a summary of the significance of what had just occurred. There was no dramatic pause before or after, no orchestral accompaniment, simply a man standing on the moon and describing what he had done in plain language, while hundreds of millions of listeners on Earth absorbed the reality of the moment. Armstrong's first observations about the lunar surface were characteristically practical and descriptive, noting that the soil appeared to be very fine-grained, almost like a powder, and that he could see his footprints quite clearly pressed into it. He reported that the surface material seemed to cling to his boots in thin layers, adhering to the fabric and rubber in a way that would prove to be one of the persistent characteristics of lunar dust, which is quite different from any dust found on Earth due to its lack of weathering and its tendency to hold an electrostatic charge. He moved about carefully at first, testing his balance and his ability to walk in the 1/6 gravity, finding that there was no difficulty in maintaining equilibrium and that the surface was firm enough to support his weight without his sinking in to any significant degree. For approximately 19 minutes, Armstrong explored alone, taking photographs, collecting a contingency sample of lunar soil in case the mission had to be cut short, and generally assessing the environment, while Aldrin remained inside the lunar module monitoring systems and preparing for his own exit. Then, at 15 minutes past 11 in the evening, Buzz Aldrin began his own careful descent through the hatch, down the ladder, and finally onto the surface beside his commander. Upon stepping onto the moon and looking around at the scene before him, Aldrin offered a description that has resonated through the decades since, characterizing what he saw as magnificent desolation. These 2 words captured something essential about the lunar landscape, which was at once striking in its starkness and utterly devoid of any feature that could be called hospitable to life. The 2 astronauts now had approximately 2.5 hours to conduct their moonwalk, which was formerly known as an extravehicular activity, and they had a list of tasks to accomplish during this time. They moved about the lunar surface with increasing confidence as the minutes passed, bouncing slightly with each step in the reduced gravity. Their white suits bright against the grey soil and black sky. There were scientific instruments to deploy, samples to collect, and a few ceremonial items that the mission planners had included to mark the occasion properly. Among the first tasks was the planting of the American flag, which was a nylon flag measuring 3 feet by 5 feet, the sort of ordinary flag that could be purchased at many retail establishments in the United States. This particular flag had been obtained from a Sears catalog and had cost approximately $5.50. A detail that somehow makes the whole endeavor feel more connected to ordinary life on Earth. Because the Moon has no atmosphere and therefore no wind, the flag had been fitted with a horizontal rod along its upper edge to hold it extended, since otherwise it would simply have hung limp against its pole. The astronauts had some difficulty pushing the pole into the lunar soil, which proved to be quite firmly packed beneath the loose surface layer, but they eventually succeeded in planting it securely enough, and it stood there against the black sky as they stepped back to be photographed beside it. The scientific instruments deployed during the moonwalk included a seismometer, which was designed to detect vibrations in the lunar surface, such as might be caused by meteor impacts or potential moonquakes, and a laser-ranging retroreflector, which was essentially a panel of special mirrors that would allow scientists on Earth to bounce laser beams off the Moon and measure the distance with extreme precision. These instruments, though perhaps less visually striking than a planted flag, represented the scientific purpose at the heart of the mission and would continue to provide data for years after the astronauts had departed. The laser reflector, in particular, remains functional to this day and continues to be used by researchers studying the precise distance between the Earth and Moon, which varies slightly over time. Throughout the moonwalk, the astronauts also left behind several items that carried symbolic rather than scientific significance. There was a small patch from the Apollo 1 mission, placed on the lunar surface in memory of Gus Grissom, Ed White, and Roger Chaffee, the 3 astronauts who had died in a fire during a launch pad test 2.5 years earlier. This small piece of fabric served as a remembrance of those who had given their lives in the pursuit of the same goal that Armstrong and Aldrin were now achieving. And though it would not be visible to anyone who might someday visit the site, its presence there was meaningful to all who knew of it. There was also a small silicon disc, about the size of a 50-cent piece, onto which messages of goodwill from the leaders of 73 nations had been etched in miniaturized form. These messages, reduced to microscopic size through a process similar to microfilm technology, represented an effort to frame the achievement as one that belonged to all of humanity rather than to any single nation. And the disc remains there on the Moon's surface among the other artifacts of the first landing. Additionally, the astronauts left behind medals honoring 2 Soviet cosmonauts who had lost their lives in the space program: Yuri Gagarin, the first human to orbit the Earth, who had died in an aircraft accident the previous year, and Vladimir Komarov, who had been killed during the Soyuz 1 mission in 1967. These medals, carried quietly to the Moon and left there on the surface, represented a gesture of respect that transcended the competition between the 2 spacefaring nations. The temperature on the lunar surface during the moonwalk was quite extreme by earthly standards. reaching approximately 280 degrees Fahrenheit in areas exposed to direct sunlight, while shadowed regions remained bitterly cold. The suits worn by the astronauts protected them from these conditions, with layers of insulation and a liquid cooling system that circulated water through tubes next to their skin, carrying away the heat generated by their exertions. The astronauts reported feeling comfortable within their suits for the most part, though the gloves, which had to be more flexible to allow for manual dexterity, provided somewhat less insulation and occasionally became uncomfortably warm. As the minutes of the moonwalk passed, Armstrong and Aldrin continued their work, collecting samples of lunar rock and soil, photographing the terrain and the spacecraft, and conducting their tasks with the calm efficiency that had characterized the entire mission. The soil beneath their feet continued to reveal its peculiar qualities, the fine grey powder compacting under their boots and leaving clear impressions. The surface undisturbed for billions of years, now bearing the marks of human presence. The sky above them remained utterly black, unmarked by any hint of the blue that would be present even at high altitudes on Earth, and the sun shone with an intensity unfiltered by any atmosphere, casting sharp shadows across the landscape. The experience of standing on the moon, though profound, was also in some ways surprisingly practical, filled with checklists and tasks, and the steady voices of mission control in their earpieces, reminding them of timelines and procedures. And yet, there were moments, as both astronauts would later describe, when the enormity of where they were seemed to settle over them, the realization that they stood on a world that no living thing had ever touched, looking back at an Earth that hung in the sky like a blue and white marble, the home of everyone who had ever lived except for the two of them at that very moment. When the astronauts returned to Earth, they carried with them something far more precious than any treasure that humans have ever sought, and that was knowledge locked within ordinary-looking stones. The Apollo 11 mission brought back 47.5 pounds of lunar material, carefully gathered from the surface of another world, and these samples were stored in special containers designed to preserve the vacuum of space around them, so that nothing from Earth's atmosphere could contaminate what the Moon had kept secret for billions upon billions of years. The containers were made of aluminium and sealed with indium metal gaskets, and they protected their ancient cargo during the fiery descent through Earth's atmosphere, through the splashdown in the Pacific Ocean, and through the long journey to the Lunar Receiving Laboratory in Houston, where scientists waited with a patience born of profound curiosity. The rocks themselves appeared rather unremarkable to the untrained eye, being mostly grey and brown and covered in a fine coating of lunar dust. Yet within their crystalline structures lay answers to questions that humanity had wondered about since the first person looked up at the night sky and felt the quiet pull of mystery. The samples were handled with extraordinary care, kept in nitrogen-filled cabinets and touched only with tools that had been meticulously cleaned, because even the smallest contamination from earthly materials could compromise the integrity of findings that would take years and decades to fully understand. Scientists wore special garments and worked behind glass, reaching into sealed chambers through gloves that were built into the walls, and they treated each fragment of lunar rock as though it were the most delicate and irreplaceable artifact ever entrusted to human hands, which in many ways it was rain. When the initial analyses began, The findings were both surprising and deeply satisfying in the way that truth often is when it finally reveals itself after long anticipation. The moon rocks were old, far older than most rocks that can be found on the surface of our own planet, and the dating methods showed ages of approximately 4.5 billion years, which placed their formation at the very dawn of our solar system itself. Earth is constantly reshaping its surface through the slow movements of tectonic plates, through volcanic eruptions and erosion, and the patient work of water and wind. And these processes have recycled most of our planet's original crust into newer forms. But the Moon has no such active geology, no atmosphere to weather its surface, no oceans to dissolve its minerals. And so the rocks that formed when the Moon was young have remained largely unchanged, waiting in the airless silence, like pages from a diary written at the beginning of time. The age of these samples aligned with a theory that had been forming in the minds of planetary scientists, a hypothesis about the violent origins of our nearest celestial neighbor. And the evidence from Apollo 11 and the missions that followed provided crucial support for what is now known as the giant impact hypothesis. According to this idea, approximately 4.5 billion years ago, when our solar system was still a chaotic place of colliding bodies and forming worlds, a planet roughly the size of Mars struck the young Earth with tremendous force. This impactor has been given the name Theia, after the Greek goddess who was mother to the moon goddess Selene. And the collision between Theia and Earth was so energetic that it partially melted both bodies and flung enormous quantities of molten rock and vapor into orbit around our wounded planet. The debris from this ancient catastrophe gradually coalesced under its own gravity, the countless fragments of what had been two worlds drawing together over thousands of years. And from this ring of molten material, the Moon was born. The theory explains many observations about the Earth-Moon system that would otherwise seem puzzling, including why the Moon is so large relative to its parent planet, why its density is lower than Earth's, and why the two bodies share such a remarkable chemical kinship. The evidence for this common origin appeared most clearly in the oxygen isotope ratios found in the lunar samples, those subtle variations in atomic weight that serve as fingerprints for planetary bodies. And the measurements showed that Earth and Moon rocks contain oxygen isotopes in nearly identical proportions, as though they had once been part of the same primordial mixture. Oxygen comes in several isotopic forms, with atoms that have slightly different numbers of neutrons in their nuclei, and the ratios between these isotopes vary from one region of the solar system to another, created by conditions in the ancient cloud of gas and dust from which all the planets formed. Each world carries its own distinctive oxygen signature, a mark of its birthplace and history, yet Earth and Moon share the same signature with such precision that they must once have been intimately connected. This finding was not immediately obvious from the first Apollo samples, requiring years of increasingly refined measurements and comparisons. But as the data accumulated from subsequent missions and ever more sensitive instruments, the kinship between terrestrial and lunar rocks became unmistakable. The Apollo program continued after that first landing, with 6 more missions attempting to reach the lunar surface and 5 of them succeeding. And together, these expeditions returned a total of 842 pounds of lunar material to Earth. Each mission visited a different location on the Moon, sampling highlands and mare basins and exploring regions that offered different geological histories. And the diversity of these samples allowed scientists to piece together a remarkably complete picture of lunar evolution. The rocks told stories of ancient volcanic eruptions that flooded vast basins with basaltic lava, of meteorite bombardments that pulverized the surface into the powdery regolith that covers everything, and of a world that had been geologically active in its youth but had slowly cooled into the quiet body we see today. One of the early findings from the lunar samples was the apparent absence of water, a conclusion that seemed to confirm the Moon as an utterly desiccated world where no trace of moisture had ever existed. The rocks showed none of the hydrated minerals that form in the presence of water, and the surface conditions of extreme temperature variations and hard vacuum seemed to preclude any possibility of liquid or frozen water surviving. For decades, this understanding held firm, and the Moon was considered as dry as any place could possibly be, a world of dust and stone and nothing more. Yet science is patient, and later observations would reveal that the initial conclusion, while correct for the samples examined, did not tell the complete story of lunar water. In 2009, a mission called LCROS, which stands for Lunar Crater Observation and Sensing Satellite, deliberately crashed a spent rocket stage into a permanently shadowed crater near the lunar South Pole, and instruments observed the plume of debris that rose from the impact. Within that plume, hidden in those dark and frozen places where sunlight has not reached for billions of years, the spacecraft detected clear signatures of water ice. The permanently shadowed craters act as cold traps, regions where temperatures drop to hundreds of degrees below zero and where water molecules, perhaps delivered by ancient comets or created by solar wind interactions, can accumulate over eons without ever being heated enough to escape back into space. The discovery changed our understanding of the Moon and opened new possibilities for future exploration, as water can be split into hydrogen and oxygen for rocket fuel and life support. Beyond the rocks and the chemistry, the Apollo astronauts left behind instruments that continue to provide scientific data to this day, demonstrating that the legacy of those missions extends far beyond the samples they returned. One of the most enduring of these experiments is the Lunar Laser Ranging Retroreflector, a panel of special mirrors placed on the surface that can reflect laser beams back to their source with extraordinary precision. Observatories on Earth regularly fire pulses of laser light at these reflectors, timing how long the light takes to make the round trip. And from these measurements, scientists can determine the distance between Earth and Moon with an accuracy of a few centimeters. The laser ranging experiment has revealed that the Moon is slowly receding from Earth, moving away at a rate of approximately 1.5 inches, or about 3.8 centimeters, each year. This gradual drift is caused by the tidal interactions between the two bodies, the same forces that raise the ocean tides on Earth. And it means that the Moon was once much closer to us than it is today. Billions of years ago, the Moon would have loomed enormous in the sky, and the days on Earth would have been shorter. And the relationship between our planet and its companion has been slowly evolving ever since that ancient collision gave birth to our neighbor. The retroreflectors require no power and have no moving parts, which is why they continue to function after more than 5 decades. Patient mirrors waiting in the lunar silence for the next pulse of earthly light. The seismometers deployed by Apollo astronauts gathered data on moonquakes for years after the missions ended, listening to the faint tremors that occasionally ripple through the lunar interior. Unlike Earth, where earthquakes are driven by the movement of tectonic plates, moonquakes have different causes, some triggered by the gravitational flexing of the moon as it orbits Earth, others by the thermal expansion and contraction of the surface as it moves between lunar day and night, and still others by meteorite impacts that send vibrations echoing through the rock. The seismic data allowed scientists to probe the internal structure of the moon, much as doctors use ultrasound to image the interior of the human body. And the findings revealed a layered world with a crust, a mantle, and a small iron core at its center. The lunar core turned out to be partially molten, a surprise that suggested the moon retained some internal heat even after 4.5 billion years of cooling. And the core's small size, perhaps 350 kilometers in radius, explained why the moon lacks a significant magnetic field today. In its youth, the moon did possess a magnetic field, as evidenced by magnetized minerals in the ancient rocks, but as the core solidified and its churning motion slowed, the dynamo that generated the field gradually wound down, leaving the moon exposed to the solar wind and cosmic radiation without the protective shield that Earth enjoys. The understanding that emerged from the Apollo samples and experiments extended far beyond our own moon, reshaping how scientists think about planetary formation throughout the cosmos. The giant impact hypothesis became a model for understanding how moons might form around other worlds, and observations of debris disks around distant stars suggested that similar collisions might be common in young planetary systems. The detailed chemical analysis of lunar rocks provided baseline data for comparing with meteorites and other planetary samples, helping to establish the sequence of events that occurred as our solar system condensed from its primordial cloud. Every world that forms carries within it the record of its birth and evolution, and the moon proved to be an ideal witness, its ancient surfaces preserving memories that Earth had long since erased. The lunar samples remain scientifically valuable to this day, stored in carefully controlled facilities where researchers continue to study them with instruments that did not exist when the rocks were first collected. New techniques reveal new information, and questions that could not even have been asked 50 years ago now find answers in those same fragments of lunar stone. Some samples have been kept sealed since their return, deliberately saved for future generations who might possess technologies and insights beyond our current imagination. A gift from the past to the unknown scientists of tomorrow. The 47.5 pounds brought back by that first mission were only the beginning, the opening chapter of a story that continues to unfold. And so the secrets written in ancient stone slowly reveal themselves, not through dramatic discoveries, but through the quiet accumulation of knowledge that is the truest nature of scientific progress. Each measurement building upon the last, each finding connected to all the others in a web of understanding that grows more complete with each passing year. The moon, which humanity once knew only as a light in the sky, has become a familiar world, its history intertwined with our own in ways we never suspected. And the rocks that astronauts carried home in their special containers have told us stories that stretch back to the very beginning of everything we know. After 21 hours and 36 minutes upon the lunar surface, the time came for the two explorers to leave behind the world they had so briefly touched, and to begin the long drift homeward through the darkness toward that small blue marble hanging in the sky. The ascent stage of the Eagle, that curious angular craft that had carried them down through the silence, now needed to carry them upward once more, to rejoin their companion who had been circling patiently overhead, waiting in the loneliest orbit any human being had ever known. Neil Armstrong and Buzz Aldrin had completed their tasks upon the surface, had planted their flag and gathered their samples and deployed their instruments, and now the moon would release them back into the void from which they had come, though it would keep forever the evidence of their visit pressed into its ancient and unchanging dust. The ascent engine fired precisely as intended, as so many engines had fired before throughout this remarkable journey, lifting the small cabin away from the descent stage that would remain behind as a kind of monument upon the plain. The lower half of the lunar module, with its spindly legs and golden foil, would stay there in the Sea of Tranquility, a permanent fixture upon that grey and silent landscape, while the upper portion rose steadily into the black sky, climbing toward the command module Columbia that traced its patient circles far above. The mathematics of orbital mechanics, those elegant equations that describe how objects fall around one another in the emptiness of space, had been calculated with such precision that the two spacecraft would meet exactly where and when the mission planners had predicted, joining together once more like old friends reuniting after a brief but meaningful separation. Michael Collins had been alone in the command module for approximately 28 hours by the time his crewmates returned to him, and during that time he had experienced something that no human being had ever experienced before, and that very few would ever experience again. Each time his orbit carried him around to the far side of the moon, he lost all contact with the Earth, all radio communication severed by the bulk of that ancient world, and in those moments he was more isolated from every other human being than anyone had ever been in the entire history of our species. The distance was not metaphorical, but rather mathematical and precise, measured in the thousands of kilometers that separated his small capsule from both the astronauts on the surface below and every living soul on the planet beyond. He was, in those quiet passages behind the moon, the most solitary human being who had ever lived, drifting through darkness with only the hum of his instruments and the gentle rhythm of his own breathing for company. And yet Collins would later reflect that what he felt during those hours was not loneliness, but rather something more contemplative, more profound in its quietude. He described an overwhelming awareness, not of his own isolation, but of the fragility of the Earth itself, herself. That small bright sphere that rose above the lunar horizon each time he emerged from the moon's shadow. From his vantage point, the entirety of human history, every war and every poem and every sleeping child, was contained within a single object that he could cover with his thumb held at arm's length. The perspective was humbling in the gentlest possible way, a reminder that all of our concerns and all of our achievements were bound together on that one precious world. Suspended in the vastness of space with nothing but its own thin atmosphere to protect it from the infinite cold beyond. Collins felt connected rather than separated, joined to all of humanity by the very awareness of how small and fragile our shared home truly appears when seen from such a tremendous distance. The rendezvous procedures went smoothly, as procedures often do when they have been practiced again and again in simulators and rehearsals, until the movements become as natural as breathing, as automatic as the beating of one's own heart. The two spacecraft approached each other with careful deliberation, their relative velocities measured and adjusted with patient precision, until at last they docked together and the three astronauts were reunited within the command module Columbia. The ascent stage of the Eagle, having served its purpose admirably, would eventually be released to drift away and ultimately crash back into the lunar surface, though the exact location of its final resting place remains unknown. Another small mystery preserved in that vast grey wilderness. The astronauts were together again, all three of them healthy and whole, and the command module began its journey away from the moon's gravitational embrace, beginning the long coast back toward home. The return voyage would take approximately 3 days, a gentle fall through space toward that growing blue sphere that awaited them with its oceans and its clouds and its millions of people watching nervously from below. The astronauts had time now to rest, to eat their modest meals, to gaze through the small windows at the star-scattered darkness that surrounded them on all sides. The moon gradually diminished behind them, returning to its familiar appearance as a silver disk in the sky, rather than the immediate and overwhelming world it had so recently been. They carried with them their precious cargo of lunar samples, those rocks and soils that would occupy the attention of scientists for decades to come, fragments of another world tucked carefully into their containers, waiting to reveal their secrets under microscopes and spectrometers in laboratories scattered across the Earth. On July 24th, 1969, the command module Columbia re-entered the Earth's atmosphere at tremendous velocity, friction heating its ablative heat shield to temperatures that would have been terrifying to contemplate had there been time for contemplation. The astronauts were pressed into their couches by forces several times that of normal gravity, their bodies reminding them that they had become accustomed to the weightlessness of space and must now readjust to the demands of their home planet. The parachutes deployed in sequence, those great billowing canopies that slowed the capsule's descent to a survivable velocity. And at last, the spacecraft splashed down into the Pacific Ocean, some 1,300 kilometers southwest of Hawaii, bobbing gently on the waves of that vast and ancient sea. The recovery ship USS Hornet was waiting nearby, its crew ready to collect the returning explorers and their precious cargo, though the welcome home would be more cautious than celebratory in its immediate execution. There remained the possibility, remote but not entirely dismissible, that the astronauts might have brought back with them some form of lunar contamination, some microorganism or unknown substance that could pose a threat to life on Earth. And so Armstrong, Aldrin, and Collins were not embraced directly by the welcoming crowds, but rather transferred into a mobile quarantine facility, a modified Airstream trailer designed to isolate them from the outside world, while scientists determined whether the moon had harbored any hazards that might have accompanied them home. For 21 days, the 3 astronauts lived within this silver trailer, first aboard the USS Hornet and later at the Lunar Receiving Laboratory in Houston, separated from their families and the adoring public by glass windows and biological protocols. They could speak to visitors through the glass, could see the faces of loved ones and dignitaries who came to congratulate them. But they could not embrace their wives or hold their children until the quarantine period had concluded, and scientists had verified that no alien microbes had hitched a ride back from the lunar surface. In the end, as many had predicted, the moon proved to be entirely sterile, a world without life of any kind, and the precautions, though wise, turned out to be unnecessary in practical terms. The astronauts were released on August 10, 1969, free at last to receive in person the hero's welcome that awaited them. The Apollo 11 mission left behind on the lunar surface several scientific instruments that would continue to function long after the astronauts had departed. Patient devices that would gather data and transmit it back to Earth for years and even decades to come. Among these was a laser-ranging retroreflector, an array of precisely aligned mirrors designed to reflect laser beams sent from observatories on Earth directly back to their sources. Scientists could measure with extraordinary precision the time it took for a pulse of light to travel to the moon and return. And from this simple measurement, they could calculate the distance between the Earth and Moon to within a few centimeters. This experiment continues to function even now, more than half a century later, still returning valuable data about the slowly changing distance between our world and its ancient companion. The seismometers left behind by the early Apollo missions also functioned for many years, detecting the subtle vibrations of moonquakes and the impacts of meteorites upon the lunar surface, revealing information about the moon's interior structure that could have been obtained in no other way. These delicate instruments recorded the moon's gentle trembling, its slow settling and occasional shuddering, painting a portrait of a world that is not entirely dead geologically, but merely deeply sleeping. The data they provided allowed scientists to understand the layers within the moon, the boundaries between crust and mantle and core, secrets that had been hidden since the moon's formation some 4.5 billion years ago. The photograph, known informally as Earthrise, though actually taken during the Apollo 8 mission some months before the landing, became one of the most influential images in human history, shaping the way an entire generation thought about our planet and our place upon it. The image shows the Earth rising above the lunar horizon, a small and delicate sphere of blue and white against the absolute blackness of space, fragile and isolated and unutterably beautiful. Many historians credit this image, and others, like it from the Apollo program, with helping to inspire the environmental movement of the following decades. A growing awareness that our planet is finite and precious, that there is no other home awaiting us if we should happen to spoil this one. The astronauts who traveled to the moon went as explorers, but returned as witnesses to the beauty and vulnerability of their own world. Between 1969 and 1972, 12 human beings walked upon the surface of the moon, each leaving behind their footprints in that fine grey dust, each experiencing the profound silence and the overwhelming perspective that comes from standing upon another world. They came from different backgrounds and carried different personalities, pilots and scientists and engineers, But all of them were transformed by what they saw and felt during their brief visits to that distant shore. Some spoke of spiritual experiences, of a sense of connection to something larger than themselves, while others described a more scientific wonder, an appreciation for the intricate workings of the universe revealed by their extraordinary vantage point. All of them returned, changed in some fundamental way, carrying with them memories that would shape the remainder of their lives. Carl Sagan, the astronomer and writer who spent his career helping humanity understand its place in the cosmos, would later reflect on another photograph taken from even greater distance. An image of Earth captured by the Voyager spacecraft as it departed the solar system, showing our planet as nothing more than a pale blue dot suspended in a sunbeam. Sagan wrote movingly about what this image reveals, about the smallness and preciousness of our world, about the foolishness of human conflicts when seen from such a tremendous distance. The cosmic perspective that Apollo granted humanity, the understanding that we are all passengers together on this small craft drifting through an enormous and largely empty universe, remains one of the mission's most enduring gifts. On any clear night when the moon hangs bright in the sky, the light that falls upon your face has traveled from that same surface where Armstrong and Aldrin once walked, reflecting off the same ancient dust that they disturbed with their boots and their equipment more than 5 decades ago. The footprints they left behind remain there still, preserved in the perfect vacuum of the lunar environment, undisturbed by wind or rain, because there is no wind and no rain on the moon, unless some future visitor deliberately erases them. Those footprints will endure for millions of years, perhaps longer, a record of human presence pressed into the soil of another world. And so we close this portion of our account with the astronauts safely home, their mission accomplished, their samples secured, and their memories preserved, drifting back into the ordinary rhythms of life on Earth while carrying with them always the extraordinary perspective of those who have seen our world from a tremendous distance and understood, perhaps for the first time, just how small and precious and beautiful it truly is.